Good night, my name is Johan Daniel Cortez. I am a mechanical engineering student. This time I will address some properties of fluids from the point of view of mechanical engineering and fluid mechanics. This video was recorded on March 21 for the fluid mechanics class with the teacher Hector Dusan. Initially, a fluid is classified as compressible or incompressible. Depending on the level of variation, the fluid density during that flow. Incompressibility is an approximation and the flow is said to be incompressible if the density remains approximately constant throughout the flow. Therefore, the volume of all portion of the fluid remains unchanged over the course of this motion when the flow or fluid is incompressible. In essence, the densities of liquids are constant and thus the flow of them is typically incompressible. Therefore, liquids are often said to be incompressible substance. Addressing the properties of fluids in general, properties are considered to be either intensivity or extensivity. Intensivity properties are independent of the mass of system, such as temperature, pressure, and density. Extensivity properties are those whose values depend on the size and extent of the system. The total mass, the total volume, and the total amount of motion are examples of extensive properties. Is water dripping from a leaky faucet falls off, spherical drops, and soap bubble thrown into air takes an spherical shape, and water forms small drops on flower petals. In these and other observations, drops of liquids behave like small spherical balloons filled with that liquid, and their surface acts like a stretched elastic membrane under tension. The tensile force causing this tension acts parallel to the surface and is due to the attractive force between the liquid molecules, and the magnitude of this force per unit length is called surface tension and is expressed in Newton meter. Another interesting consequence of surface tension is the capillary effect, which is the rise or fall of liquid in a small diameter tube inserted in a liquid. Such narrow tubes or confined flow channels are called capillaries. The rise of kerosene through a cotton wick inserted in the container of lamp with this fuel is to this effect. The capillary effect is also partly responsible for the rise of water to the top of the dress. The curve-free surface of a liquid in capillary tube is called a meniscus. Thank you very much. I hope you enjoyed this video.